Hello everyone, I am your friend Shadab Imam and we are continuing our lecture series on operations research. If you are new to the channel, please subscribe the channel and don't forget to hit the bell icon. So today I have came up with another interesting problem of assignment model, and we will see how this problem can be solved by Hungarian method. So let us see what Hungarian method is or what steps we need to follow. So first of all, we need to make sure that our matrix is a square matrix. Then we need to reduce this matrix in such a manner that each row and each column must contain a 0. Third step is to make assignment, and if we get an optimal solution after assignment, the value of z is obtained, and if our current solution is not optimal, then we will move to step 4, which is to draw minimum number of lines crossing all the zeros. So these are some steps we need to follow to draw the minimum number of lines crossing all zeros. And after this we need to create a new assignment matrix, and we also have certain steps here to make the new assignment matrix. And after making the new assignment matrix, we will try to assign in that particular matrix. So if the solution is optimal, then we will calculate the value of z. If our solution is not optimal, then again we will go to step 3 and repeat the procedure till an optimal solution is not reached. So let us quickly move on to the question. So here the question says that there are 1, 2, 3, 4, 5 facilities and 1, 2, 3, 4, 5 jobs. So we need to assign this for minimum cost. And first of all, step 1 says that prepare a square matrix. So as we can see that this matrix is also already a square matrix, a 5 cross 5 matrix. So this satisfies the first step. And moving on to the second step is to reduce the matrix. To reduce the matrix, we need to follow row reduction and column reduction. In row reduction, what we will do is we will select the minimum value in each row and subtract all the elements in that row by that particular minimum value. So let us do a row reduction here. For row 1, the minimum value here is 8. So this is 11 minus 8 is 3. 17 minus 8 is 9. 8 minus 8 is 0. 16 minus 8 is 8. 20 minus 8 is 12. Similarly, in row 2, the minimum value is 6. So 9 minus 6 is 3. 7 minus 6 is 1. 12 minus 6 is 6. 6 minus 6 is 0. 15 minus 6 is 9. For the third row, minimum value here is 12. So this is 13 minus 12 1, 16 minus 12 4, 15 minus 12 3, 12 minus 12 0, and 16 minus 12 4. For fourth row, minimum value is 17. So 21 minus 17 is 4. 24 minus 17 is 7. 17 minus 17 is 0. 28 minus 17 is 11. And 26 minus 17 is 9. Now fifth row, the minimum value here is 10. So 14 minus 10 is 4. 10 minus 10 is 0. 12 minus 10 is 2. 11 minus 10 is 1. 13 minus 10 is 3. So as we see that after row reduction, we are having zeros in each row, and we need to make sure that we also have 0 in each column. But as we can see, the first column does not have 0 and the last column also is not having a 0. So again, what we need to do, we need to go for column reduction. For column reduction, we will follow the similar procedure. We will select the minimum value in column. So for column 1, minimum value is 1, and we will subtract each element in this row by this minimum value. So this is 3 minus 1, 2, 3 minus 1 again 2, 1 minus 1 is 0, 4 minus 1 is 3, and 4 minus 1 is 3. Now for column 2, column 3 and column 4 we are having zeros, that means the minimum value is 0. So the column 1, column 2 and column 3 will remain unchanged because anything minus 0 will remain as it is. So this will be 9, 1, 4, 7, 0, then 0, 6, 3, 0, 2, then 8, 0, 0, 11, 1, and in the last column we can see that the minimum value here is 3, so we will subtract each element by 3. So 12 minus 3 is 9, 9 minus 3 is 6, 4 minus 3 is 1, 9 minus 3 is 6, 3 minus 3 is 0. Now we have zeros in each row and in each column, so we have completed the step 2 to reduce matrix where we have zeros in each column and in each row. Okay, now the next step is to make assignment. So for assignment, first we will assign row wise, then we will assign column wise. Okay, so if there is a single row, single zero in a row, we will assign it, and if there is more than one zero, then we will skip that row and move on to the next row. Similarly we will do with column also. So here we can see that for row 1 we have single zero, that means we can assign this 0. So I am assigning this 0. Once this 0 is assigned, that means no more assignment can be done in this row and in this column. And in this column we can see that there is one more 0 present. So once this 0 has been assigned, this 0 becomes ineligible for assignment. So I am crossing it out. Now moving on to row 2. In row 2 we can see that there is a single 0. So we will assign this. And once this is assigned, no more assignment can be done in this row and no more assignment can be done in this column. So there is one more 0 here. So we will cross it out because this has been already assigned, so no assignment can be done here. Now moving on to row 3. In row 3 there are two zeros, but one 0 has been already crossed out. That means there is only one eligible 0 in row 3. So we can assign this 0. So we are assigning this 0 here. And once this is assigned, that means no more assignment can be done in this column and no more assignment can be done in this row. Now moving on to row 4. Row 4 has a single 0, but this 0 has been crossed out. That means this is ineligible for assignment. Now moving on to row 5, we have more than one 0. So we will skip this and we will move column wise assignment. So for column 1 we see that we already have an assignment. So we'll move to column 2. In column 2 we have a single 0 here. So we will assign this 0. And once this 0 is assigned, that means no more assignment can be done in this column and no more assignment can be done in this row. So once this has been assigned, this 0 has to be crossed out. Okay, so moving on to the next column. Column 3 has already an assignment. Moving on to the column 4 has already an assignment. Moving on to the column 5 has no assignment because there is one 0, but it has already crossed out. So as we can see here that we have 4 assignments in a 5 cross 5 matrix, and we know that to get an optimal solution we need to have the number of assignment equal to the order of matrix. That is, if the matrix is 5 cross 5, we have to have 5 number of assignment, but instead of that we are having only 4. So what we need to do here is follow the step 4, that means draw minimum number of lines crossing all 0. So let us see how we draw minimum number of lines. So first of all, take the all unassigned row. So in these rows only one row is unassigned, so take the unassigned row. So this is unassigned row. Now if this row has a 0, take the corresponding column. So this row is having 0, then take the corresponding column. Now if this column has an assignment, take the corresponding row. So this column is having an assignment, so take the corresponding row. Okay, so now no more ticking is possible. And now what we need to do is draw lines through unticked rows and ticked columns. So we need to draw lines through unticked row. So these are unticked row 1, 2 and 3. Okay, and ticked column. So as we can see here that there are 3 types of cell here. First is where no lines are passing. So these cells 2, 9, 8, 9, 3, 7, 11, 6. These are the cells where no line is passing. And there is another cell where single line is passing. 2, 1, 0, 0, 6, 1, 0, 4, 0. Okay, these are the elements where single line is passing. And the third category is where 2 lines are passing. So as we can see, this cell having the value 6, this cell having the value 3 and this cell having the value 2 are the cells in which 2 lines are passing. 2 lines are crossing each other, that means 2 lines are passing. So what we'll do here is we will select the minimum value, say theta. Okay, we will select any minimum value theta among the cell where no lines are passing. So when we see the cell where no lines are passing, the minimum value here is 2. So the value of theta is 2. Now what we'll do is the cell where no lines are passing. If a number has no lines passing through it, then Cij, that is the new Cij, is equal to Cij minus theta. That means the new cost coefficient will be the older cost coefficient minus of theta. So here we can write this is 2, 2 minus 2 is 0, 2 minus 2 is 0, so this is 0. Similarly 9 minus 2 is 7. Now this is the cell where no lines are passing. 8 minus 2 is 6, 9 minus 2 is 7. Similarly then we have these 4 cells where no lines are passing. So 3 minus 2 is 1, 7 minus 2 is 5, 11 minus 2 is 9 and 6 minus 2 is 4. So only these cells are having no lines passing through it. Now moving on to the cell, if a number has one line passing through it, then new Cij will be equal to the older Cij. That means the cell in which only single lines is passing, then the cost coefficient in the previous matrix will remain as it is. So this will be 0, this will be 2, 1, 0, 6, this will be 0, 4, 0, 1, this will be 0, this will be 3, 0, this will be 3, 0, 1, 0. Okay, so now moving on to the third type, where if a number has 2 lines passing through it, then Cij is equal to Cij plus theta. That means the new cost coefficient is equal to the older cost coefficient plus theta. So as we can see here, this is 6. So 6 plus theta, that means 6 plus 2 is 8. So this will be 8. 3 plus 2 is 5. And 2 plus 2 is 4. So now we have obtained a new matrix here, and we will try to assign in this new matrix. So let us follow the same procedure for assignment. So starting from row 1, in row 1 we can see that we have 2 zeros or we can say we have more than one 0, so we will skip this and move on to row 2. In row 2 we have single 0, so we can assign this single 0 here, and once this 0 has been assigned, no more assignment can be done here, and similarly no more assignment can be done in this column. So once this is assigned, this 0 is crossed out. Now moving on to row 3. In row 3 we have two zeros, but this 0 become ineligible, so it has only one assignable 0. So we will assign this 0 here, and once this 0 is assigned, no more assignment in this row and in this column is possible. So in this column there is another 0, so it has to be crossed out. Now moving on to row 4. In row 4 we have a single 0 present here, so we will allocate this, and after allocating this, no more allocation can be done in this row and no more allocation can be done in this column. So once this has been assigned, that means this 0 has to be crossed out. And now moving on to row 5. In row 5 we have more than one 0, so we will skip this and we will move column wise. So in column 1 we already have an assignment, and moving on to column 2. In column 2 we have a single 0 here, so we will assign this 0, and once this 0 is assigned, no more assignment can be done in this column and no more assignment can be done in this row. That means once this is assigned, this 0 has to be crossed off. Now moving on to column 3, there is an assignment, column 4 there is an assignment, and column 3 there is no assignment. Okay, now as we can see here, we have 4 number of assignment, but to have an optimal solution we need to have 5 assignment, which is equal to the order of matrix. So again what we'll do here is we'll draw minimum number of lines by the same method as we have written there. So what we'll do is take the unassigned row. So this is the unassigned row. Take the unassigned row. If this row has a 0, so these are having two zeros, so if this row has a 0, take the corresponding column. So this is corresponding column and this is also the corresponding column. And now if this column has an assignment, take the corresponding row. So this is having an assignment, so we will take the corresponding row. Again this column is also having an assignment, so we will take the corresponding row. Now we need to see that we will find out that there is one row where there is one more 0 coming. So this ticked row, if this is a 0, unassigned 0 here, then we will take the corresponding column. So we will take this corresponding column, and if this column is having an assignment, then we will take the corresponding row. So now no more ticking is possible, and we need to draw lines through unticked row and ticked column. So there is only one unticked row, so this is unticked row and ticked column. This is ticked column. Okay, now again we have 3 types of cell here. First is where no lines are passing, so these are the cell where no lines are passing, and the second is the cell where single line is passing, so these are the cell where single line is passing, and the cell where 2 lines are passing. These 3 cells are there where 2 lines are passing. So as we know that we will select a minimum value among the cells which has no lines passing through it. So among them we will select the value of theta. So among these value, the minimum value here is 1, so theta equal to 1. Now for the cell which is having no lines passing through it, the Cij, that is the new Cij, is equal to the older Cij minus of theta. Okay, Cij minus of older Cij minus theta. So this is 7 minus theta, that means 7 minus 1 is 6. 7 minus 1 is 6, so this will be 6. Then 1 minus 1 is 0. 4 minus 1 is 3, 5 minus 1 is 4. Now moving on to this, 7 minus 1 is 6, 6 minus 1 is 5, 1 minus 1 is 0, and 4 minus 1 is 3. Now moving on to the cell which have only single line passing through it. So for the cell having single line passing through it, there will be no change. That means the older Cij will be equal to the new Cij. So we will write these values as it is. So this will be 0, 2, 0, 1. This is 0, 8, 5, 0. This is also 0, and 6, 0, 0, 9 and 0. And now there are 3 cells where 2 lines are passing. So for the cell having 2 lines passing through it, the new Cij will be the older Cij equal to older Cij plus theta. So this is 3, 3 plus 1 is 4. So this will become 4. Similarly this is 4, 4 plus 1 is 5. This will become 5. This is 1, 1 plus 1 is 2. So again we have been able to make the new assignment matrix here, and again we will try to assign in this particular matrix. So as we can see here, we will start from row 1. In row 1 we have 2 zeros, that is more than 1 0. So we will skip this row. Moving on to the row 2. In row 2 we also have 2 zeros, so we will skip this. In row 3 we have 3 zeros, so we will skip this. In row 4 we have a single zero. So in row 4 we are having single zero, so we will assign this 0. And once this is assigned, there can be no allocation in this row and in this column. So once this is assigned, this 0 has to be cancelled out. Okay, now moving on to row 5. In row 5 we have more than 1 0, so we will skip that. And again we will see column wise assignment. In column 1 we see more than 1 0, so we will skip this. In column 2 we will see more than 1 0, we will skip this. Column 3 has one assignment, so we will skip this. Column 4 we have more than 1 0, so we will skip this. And column 5 we have more than 1 0, so again we will skip this. So as we can see that in most of the places we are having more than 1 zeros and we have to skip that value. But because of making this assignment in our first row, previously there was 2 assignable zeros, so we had skipped. But now since 1 0 has been cancelled out, we will again consider assigning row wise, and we will see that in row 1 there are 2 zeros but 1 0 has been cancelled out. That means there is only one eligible 0 for assignment, so we will assign this 0. Once this 0 is assigned, no more assignment can be done in this row and in this column. So once this is assigned, this 0 has to be cancelled out. Now moving on to row 2, we have more than 1 zeros, so we will skip this. Moving on to row 3, we have more than 1 zeros. Okay, so we will skip. Moving on to row 4, we have an assignment, so we will skip this. Moving on to row 5, we have more than 1 0, so we will skip this. Now again we will see column wise. In column wise, column 1 has assignment, so we will skip. Column 2 has more than 1 0, so we will skip. Column 3 has one assignment, so we will skip. Column 4 has more than 1 0 and column 5 has more than 1 0. So again we are having a situation where row wise and column wise there are more than 1 zeros in each row and in each column. So we are unable to assign here. So what we will do here is we will select any one of the assignment, and according to that assignment we will assign the values in the other cell. So I am selecting this for assigning. So once in row 2 I have selected this for assignment, that means no more assignment can be done in this row. So this 0 has been cancelled out. Similarly, no more assignment can be done in this column, so this 0 also cancelled out. Now moving on to row 3, we can see that there are more than one zero, so we will skip. Row 4 already had assigned. Row 5, now there is one assignable 0 present. Previously there was 2 0, but 1 0 has been cancelled out, so there is only 1 0 or one assignable 0 present. So we will assign this 0, and once this 0 has been assigned, no more assignment can be done in this row or in this column. So this 0 has been cancelled out because this column is already having an assignment. Now moving on to the column wise assignment. Column 1 is assigned, column 2 is assigned, column 3 is assigned, and column 4 is now having a single assignable 0. Previously this is having more than one 0, but now once this 0 has been cancelled out, we are having only single assignable 0, so we can assign this 0 here. And now after assigning this, we are having total 5 number of assignment. That means now our solution is optimal. We have 5 assignments, which is equal to the order of matrix. Now we need to find the value of Z minimum here. Now to obtain the value of Z minimum, we need to see that this optimal solution is also optimal for this initial matrix. So what we'll do here is we will see where we have assignment in this cell, and we will add up the values of this particular matrix. So for 1 1, we can see that value here is 11, plus this is 2 2, the value here is 7, plus 7, this is 3 4, so 3 4, value here is 12, so this is 12, and this is 4 3, 4 3, value here is 17, so this is 17, plus, and this is 5 5, so the 5 5, value here is 13. Now after adding all these, we will get the value as, this is 30 20 50 60, this is coming as 60. Okay, so for this particular problem, the value of Z minimum can be 60, and the optimal solution has this assignment. So we will write the assignment. So 1 has been assigned to 1, 2 has been assigned to 2, 3 has been assigned to 4, 4 has been assigned to 3, and 5 has been assigned to 5. So this is the optimal assignment we get, and for this optimal assignment, the minimum value of Z is coming as 60. So hope you like the lecture. If you like the lecture, please share the lecture. Have a nice day. Thank you.